Hello everyone. In this video, we will see how to design a finite state machine. First, we will make a state diagram, and using that, eventually we will design a sequential circuit. So let us see our problem. Design a FSM to detect more than one ones in the last three samples. So the question requires us to detect these four patterns simultaneously, such that if such pattern comes to our machine, the output will be 1, else the output will be 0. For example, if 000 or 001 comes, then the output will be 0. For such problems, an easy way to deal is to track the last two digits, the last two samples of our machine. For example, if 01 were the last two inputs, then the current state would be S01, which means that 01 is already detected. So if a new input comes, for example 01, and a new input 1 comes, then the next input will transition, the next state will be transition to 10 state. Such machines are also known as Mealy machine, where the state transition is decided by the current input. So let me make the state diagram for this problem. My states are S00, S01, S10, and lastly S11. My reset state would be S00. So whenever a reset input is given, the machine will start from this state. Now let us begin. If 0 is coming continuously, it should stay in S00. So output will be 0. Now let us see all these four patterns one by one and try to map them on our state table or state diagram. So let me begin with 0, 1, 1. So already if 0 has come, so it will be in S00. If 1 comes, then it will move to S10. Output will be 0. If another 1 comes, then it will move to S11, and in which case the output will be 1, because 0, 0, 1, 1 is detected. So what I am doing is that based on the current input, I am transitioning my states. So 0, 1, 1 is completed. Next is 1, 1, so 1, 1, and another one will make us transition to the same state, because it will still be 1, 1 detected. So output will be 1 here. This one is over. Now for 1, 1, 0, 1, 1, and 0 will transition to 0, 1 state. Output will be 1. Now lastly, for 101 state or the 101 pattern, 1, 0, and another 1. So the transition will look like this. So in this case, for 0 here, and for 1 the output will be 1. And for the remaining case, if 0 comes in 0 1 state, it will transition to as 0 0 and output will be 0. So we are finished with our state diagram. Let me make some space. The next step is to make a state table. This will be useful for solving our K-map and eventually design the sequential circuit. So I'm taking my input as X, and the two states are QA, QB, QA plus and QB plus are my next state, and Z is my output. So let me fill the state table. So now let us see the transitions. If we are in 0 0 state and 0 comes, then it remains at 0 0 and output is 0. 0 0 0. And for input 1, it should transition to 1 0 state. Output is 0. For 0 1 state, if 0 comes, it should go to 0 0 state, output 0. If 1 comes, then it will go to 1 0 state and output is 1. For 1 0 state, if 0 comes, it should move to 0 1, output 0. If 1 comes, then it moves to 1 1 state, output 1. Similarly, for 1 1 state, if 0 comes, then it moves to 0 1, output 1. 1 1, output 1. So our state table is over. Let me minimize it. Minterms are M0, M1, M2, 3, 4, 5, 6, 7. Now I'm going to solve 3 K-maps for these 3 variables. X, Q, A, Q, B, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, 2, 3, 4, 5, 6, 7. So for QA plus, my minterms are 4, 5, 6, 7. It is forming a quad, so we can group them. So my QA plus is X. We got our first equation. Similarly, for QB plus, QA, QB, 0, 1, 0, 0, 1, 1, 1, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7. Here the minterms are 2, 3, 6, 7. So again a quad. So QB plus is QA. Our second equation is ready. And finally for our output Z, again 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7. My minterms are 3, 5, 6, 7. So only a pair is happening here, so we will group them. So Z equals to X and QB plus X and QA plus QA QB. So this is our third equation, which is also the output equation. Now, as said earlier, we would require 2 flip-flops for this. So I've taken 2 flip-flops. And a synchronous clock. So since we know that for D flip-flop, the next state is what is occurring at the input. So we will directly apply input in flip-flop A, and the input of flip-flop B would be the output of flip-flop A. And to design the output logic, I will make it separately. So the inputs are XQB, XQA, QA, QB. So the outputs here, signals basically here, here and here, are given as input to this combination block, which will generate my output signal Z. So this is our final design. Hopefully this video was simple enough to show a step-by-step approach how to design a finite state machine. If there are any suggestions, please let me know in the comment section below.